for the API piece, but not for the entire API management platform, but specifically for the testing piece. You'll see that that is actually something where a lot of the time is invested in good APIs and with enhanced and lifecycle APIs. With the entire piece of API management, you need to test them if they're still consistent after you did or added a single function, a small change, and things like that. And why not play AI to help you generate all the test assertions, the regression test cases, and the whole block, and have it tested automatically and give good insights if things are running well or not. And we'll walk through how it actually works and is applied to the capabilities. So you will see that there will be a demo of the GOFA, the goal-oriented flow assist, and also for the API testing piece. Okay, the first part is more about getting started, setting the scene. So what are we talking about here in general? And essentially, it is all about the API management piece to set the stage of the scene. So it is a lot about creating APIs and testing. That's for the testing piece. So you have to see that your application developers are building the correct functions. They are building a meaningful, interpretable API specification that you can use in context. And then the entire piece is basically forwarded, and you have a discipline also in API management to see that it's properly secured. So basically apply built-in and extensible policies to secure, to basically see that, for example, a banking application is secured using the correct credentials, using OAuth or OIDC, and all this is basically handled by the discipline of API lifecycle and management as well in that sense. Management, certainly you want to rapidly publish, govern, analyze the usage of APIs and products. And as developers are changing versions, like adding new parameters and new capabilities to it, it needs to be managed, it needs to be properly released and maintained so you can socialize it properly. And in the socialization, you more or less enable the discovery of the APIs and empower internal or external application developers to find APIs, to learn about the APIs, and so certainly to subscribe and register the applications to it. So to provide a whole level of self-service, for example, with the developer portal, and that basically kind of closes the API lifecycle. There's always connections in between. The socialization also happens between the, and we see it on the next slide a little bit, between the API developers and the API consumers as well. So there's a couple of roles involved, and they all basically have a good potential to receive support through AI enablement. It kind of always starts with the API developer who's building new integrations, and he's basically exposing APIs, and the integration piece, we'll see that later, is meant to be without extensive training, but at least from the API developer side, there's a key role in this entire lifecycle that we've just seen. But certainly also the product manager who's putting together a catalog of the APIs that have been built and applies things like rate limiting, things like monetization, and basically decides on the lifecycle and the whole control of the API to be published internally or externally to the catalog there. The consumer, API consumer, is basically a discipline where you can divide basically your audience between providers and consumers. There's a level of provider organizations that you can basically virtualize your API management deployment, but also API consumers are kind of grouped, so you can see which group is basically getting what kind of priorities, can get what kind of plans to consume the APIs, etc. So there's quite a bit of separation into different provider and consumer organizations going on there. And then the rest, the DevOps piece, to properly pipeline the deployment, not only of your API management infrastructure like gateways, APIs into the gateways or into your API management for the API developers, and a whole range of things that you can easily automate these days, especially with the deployment on a cloud-native platform into containers. There's a high level of automation specifically for the DevOps side of things, and for Kubernetes basically to control, to scale and to HA your entire deployment there on the DevOps side. And yes, there's always work for an architect here in these entire pieces, but I want to basically bring together the API and the integration side a bit, because oftentimes when you expose an API, a lot, or if not most of the work happens behind the scenes there. And integration traditionally has been a large team sport, at least in larger organizations, with very dedicated roles and teams and collaboration between them, you know, starting from integration administrators or developers, or then back to backend developers and database administrators, potentially designers, and then all the way to someone who builds an API from the backend systems or combines different applications into a single API, and then eventually to test those APIs. So the API, or the value of an API, comes from much deeper than just the portal where the application developer finds it and basically consumes it. And our intent, especially with the application of AI, is to make this life easier and to basically combine typically these roles maybe in single people. So the trend is a bit from the people side of things to start maybe decentralizing those responsibilities and enable maybe more decentralized teams to pick up integration pieces, API exposures and things like that. And for that you certainly need to lower the entry burden and to make life easier to build such an integration. And one of these pieces for that is our App Connect Designer. That is the integration piece here, which is a very guided experience without coding, where you can get certain, you know, or a whole range of integrations done. Specifically these days with very hybrid platforms and many of the core application platforms hosted as a service. There is a very good means with this kind of application building to find an easy and guided and intuitive user interface that is part, you know, that basically comprises of connectors to connect those two applications, and that expose it as an API at the end of the day. So the combination of integration into API management is a discipline that we are pursuing with our tools, certainly to a good extent. It's all about increasing productivity, certainly, reduce the time to market for these things, and make it basically scalable and secured and standard-based in all the disciplines here. Right, so going forward, we see this in the demo a bit more as a practical example, how you build these, but it is more or less based on a whole catalog of connectors that is constantly extended and exposed, and it goes from different things like, you know, just connecting to standard-based platforms like SAP and Salesforce with their entire range of objects and domains they have there, to specific only technology endpoints where you need to transform data formats and things like that. So with a even very visual impression of building an integration, we can go straight to, you know, major platforms and applications, but also do the transformations and the tooling that is necessary in between to fulfill and to create a use case like that. And yes, essentially that is our base for application integration. And let's get back or get into the details a bit. How would you apply AI to this kind of use case? One of the use cases we found is basically to assist a developer or an integration developer in building such a flow, and maybe based just on a natural intent or language expression, what he does. So he's meant to describe his integration requirement in natural language, and we're trying to help automate it by generating at least the base flow and the base mapping between the objects for him. Doesn't have to be perfect, but often it is the case. You're getting a properly ordered and aligned integration flow presented when you do this, and you're getting a very well-designed mapping of the objects of the different connectors, basically. You know, that first name maps the first name, and street and number basically match the street object on the other side. So AI is very helpful in these cases to detect matching pieces there, and that's also a second use case that is going through this here. Looking a bit more under the hood, the entire piece of the goal-driven digest the natural language and the utterance, so the spoken intent of the developer, and can decompose it and can plan out a proper integration flow based on the knowledge graph that it has. And yeah, basically it comes up with the proper mapping. You can see there's still exceptions in here, but in the UI you will see that it's just based on the connectors not having the proper authentication yet. In the demo that is done for the individual connectors, and by that the AI planning can basically best match the goal to the candidate components and provide you a well-working and integrated connector flow. A bit more details on this. The GoFar system basically is a GoFar server. It starts with the utterance, so that is the intent. I want to basically integrate, whenever there's basically a new opportunity created in Salesforce, for example, I want to get a notification on Slack, and I want our marketing to be notified via Gmail or something like that. If you speak this out in a sentence, if you type it in as a starting point, this utterance is basically being digested by the AMR service, which decomposes it, understands what a system is and what a type of integration is based on your phrasing. And then this is handed over to the knowledge graph that we've seen before and mapped to proper connectors and the object model that is behind it to properly map it to the goals that you're intending to do. And then the third component in there is the AI planner that can actually properly sort out the order of the connectors and the way that the flow has to properly operate to make it digestible and really functional and operational. So that is an AI planner capability there. And then it all comes back as a YAML file, which is a base description or description language for our integration flows, and that can be handed over to the App Connect designer, and you can work with this practically there. You can also test it as a cloud service. We'll see this in the product right now, but as part of the demo, we show it as a cloud service as well. So, yeah, let's get to a small demo of this. I think I'll do the demo now before I do the API testing piece, just to get this quickly done so you don't lose the context. Let me see that this is switching properly. 1 second. All right, so this is showing App Connect as part of our integration platform, the Cloud Pack for integration. And you can see there's different starting points to build an API, specifically if you want to build it with your own hands-on. Event-driven, that monitors one of these platforms if a change is happening, if something new is created and it kicks off a flow. Or you just build an integration and you expose it as an API and hand it over to API management. Those are the core two use cases. But there's even a higher level entry point, which is creating the flow by describing an integration. And that is the new piece here. And basically you get a UI to describe, obviously. And if you don't know where to start, there's a couple of suggestions. I think that's how it's being used right now. You can also see the range of templates that are available. So integration flows that have been previously built. And yeah, one example, it could be, for example, if you want to, in our case, open a ticket in ServiceNow from an identified issue in Slack, which is monitoring, you send an email to a Gmail account, for example. It's just one artificial use case, if you will, but it technically makes sense in context of the connectors that we've seen here. And obviously then the system will go ahead and do two things. One is to build you a brand new integration flow, but also to look, and that's the part below here, what are existing recommended assets where someone has built something like this before. So you could use these as a higher level starting point. And you always see the probabilities here, so the level of match here, for example, for the individual connectors that we're using based on your description. And you get a preview of the raw integration flow basically to get things done. And once you're happy with that, you would move on and actually open this piece in the designer, which is coming up next. yes, that's the natural flow. I could also maybe envision something where you speak into a microphone and get this done. But eventually you can see it's sorting out the proper connectors. It shows you the context, so why it came up to this conclusion, and what other alternatives there would be. So you could even potentially switch the connector if you think it's doing something wrong, but it's also learning from this exercise. So once you're done with this, as another example, you could, it's basically pursuing two different options. One is sync new Salesforce leads with insightly leads. Okay, that's just a simple sync exercise. And this one is actually taken over to the App Connect Designer. And the second capability in here is basically to do mapping of the data elements and objects within these two connectors, if you will. You get a range of suggestions here. It's as well salutation, type, email. Those are simple, but there should be a couple like mobile and mobile phone that are not a perfect match, where AI takes basically an attempt to do the mapping for you and helps you a lot. So this is typically also an exercise that can consume quite a bit of time to get it done and properly, and AI can support you with this mapping exercise. So you can basically accept those suggestions and then start the flow, and that more or less productionizes your flow here in the environment you're living in, based on the configuration and based on the suggested mapping here. And you can see the flow is running, and the second part could be that you actually do something in Salesforce and you see it comes up in Insightly as one example, but those connectors are working properly. The other starting point that you can do, if you don't want to do it straight in the product, is actually go straight to a website that we provide. The link is actually in the deck. This is the more experimental side of this flow generator. So we offer this publicly, so you can log in with your IBM ID, and this always gets the latest and greatest features and updates. So you can also create an integration in this one as well. But you would then export the YAML file and import it into a proper App Connect environment that you can use on IBM Cloud, or maybe even own one if you're an IBM customer already. That is even a bit more extensive experience here with capabilities to describe the flow and to get this organized. Okay. Right. So these are the core things for the Gopher, Goal-Oriented Flow Assist, where we think this is one good use case to apply AI and to have a level of assistance here for building integration flows. And the second part of this, or the second application of AI we're having in our products, is basically on the API Connect side, so the core API management product, which has an extension for automated test generation now, and this is heavily assisted with AI here. So the idea behind it is that you're typically basically using a lot of time to create tens or maybe hundreds of test cases in your regression. And that's quite a manual exercise. It's something that needs to be maintained and kept up to date, especially when you extend an API, to really see that it's still consistent after your versioning, enhancement, and evolution. And why not use something like this to automatically generate those test cases without writing the test cases manually anymore. So there's no production data needed. That's the specific part of this type of testing. It is basically dependent on a well-specified open API document where all your objects and your domains, etc., have to be quite well defined. So which endpoints will be invoked, maybe in which order, if they have clear parameter definitions. So then the tool can basically pick it up and nicely generate test cases against it for the different operations, get, post, delete even in there. It is intelligent enough to see the proper order that you need to create or post an object first before you can delete it. It knows, for example, if you if you post something and don't get an ID for the next operation back, it can't continue, and this test case has failed. And all these things you will see in the report that is generated then afterwards. So the concept behind it is called biased random request generation. So it is always biased to basically creating correct test case and correct submissions, and it will kind of stop when it sees this flow is broken, and it will show that this path of testing is basically not leading to success here. So it's unlike plain random where it just generates hundreds of tests and kicks them off one after the other. So there's a level of intelligence, and it's learning from the responses that it's getting from the backend systems then.
Excuse me.
Yes.
Can you just stay here because
yeah,
for the microphone, because here in the room it's cool, but
that's fine. That's fine. Okay, thanks.
You're welcome.
Yes, so it is, in our case, integrated obviously into the product and the UI, and it's validating the responses against the Open API specification, and you can see it as reports, obviously. Technically, it is a test generation framework. You could even take this framework, which we have published, and use it against your own test framework if you want, but obviously we've built it as a complete solution in our own test solution that we have. And you can nicely see how basically the API specification is fed into an analyzer which derives the semantics from the API and provide or creates a semantic model based on the API that you've created. Yes, it knows about all the resource dependencies and basically sends them to the resource checker, which is learning from the request and response that is happening here on the lower part. So there's a generator and a checker piece who are creating requests, and the checker is basically validating the response that's coming back and creating an internal state. But it's not completely autonomous. The tester has a level of influence on that for test creation by defining scopes for the test, like focus only on post operations, for example, and potentially neglect all the other operations. So then the test generation will only go into the post space and create lots of interaction on that level, and you can see that it's testing there. Or maybe a bit more security focused, that can all be specified by the tester in the extension piece there, or test against the top 10 OWASP security vulnerabilities and stuff like that. So they can all be influenced to a good extent by the tester. So let's look at a demo of that as well. See how we're doing time-wise. Yeah, should be good. And let me exit this guy. And again, we're starting in our Cloud Pak deployment. So the Cloud Pak is basically our platform-style deployment of all our integration capabilities. So not only the App Connect that we've seen before, you will see on your Cloud Pak for Integration Navigator, but also your API management, your MQ messaging, or your Kafka event streaming, and all these pieces can be deployed into a single platform experience based on Red Hat OpenShift in this case. But we are looking at the API piece, obviously. So you can open up your design experience here, the UI straight from the navigator, or just obviously bookmark it and go straight here. And here, this is kind of the overview of the experience. We're just focusing on the API testing, but basically everything comes together in one place here for your different roles for developing APIs and products, managing the catalogs and publishing it to developer portals at the end of the day, and then manage the settings and resources, so your different gateways that you want to publish to, for example, if it's different ones in different cloud environments. It all comes to one piece, and you have a high level of control how your entire API network and architecture is being deployed and handled. Or just a simple starting point to connect or download the toolkit. So it's all about not being forced to use the single user experience. You can use the API tooling of your choice and use the toolkit to publish into the platform, so that the API management is done by the product itself and everything else can be handled as you like. So we're looking at API testing here, which is opening up from this UI. And you can see it is using, in this case, we're using a bookshop API and already created a so-called test suite, which contains or is comprised of several tests that you can create. But you will see in this one, I didn't really create any manual test cases here. Oh, I think I have to wind this back a little bit. Which you could do, certainly, just like a traditional test platform. You can create lots of assertions manually here and build it up massively from here for test cases. But we want to look into the AI support here, which is based on a test profile that you create. So you're basically, in this case, you can just either select the API that is coming from the catalog because it's in one system, or you can just feed it your OAI 2 or 3 specification that is hopefully quite well built and for the AI to be understandable. Obviously, for our bookshop API, we nicely built this, and so the demo, which we call Apidays, is able to basically extract, to decompose it, extract extension points where the tests are coming from. And then on the next stage, when you have saved and edited this extension profile, you can set your priorities or your configuration here. So one is, for example, if there's no URL endpoint in your API spec, you can add it here so the thing is running and working. But you can also control other things like the time to run or the number of errors that it's meant to digest. So if, for example, the maximum request is 0, that is endless, so we'll just continue to run and create requests. But you can certainly time it to say it's something that is to be done by 5-10 minutes or maybe even an hour or a whole day if you want to. So it's always continuing and doing the testing depending on yours. But one good limitation is the maximum number of errors, where it would just stop and then you have a limitation on that end. But another important piece is the operation. So you can nicely set weights or focus on what this test suite is supposed to do. So for the operations, you can, for example, nicely say, well, I only want to focus on post operations and give it a higher focus value here, and all the other operations you would just clear out of this piece, and then you have a very strong focus on going on post operations here. And the similar thing would apply for security specific testing, and that is all done in the configuration piece, which is still yes, you provided security credentials here, so it works, but there's also a way to test specifically against it and enhance the configuration here. So we can save it away, we can run it, and that is certainly something that is firing away individual calls that you can look at as well, certainly to use it for other or for manual use cases if you like to. But you can see it went through quite a range of calls that have been made, quite a number of failures that might be expected as well. And you can then stop it or run it at a specific time and really can see what, this is going quite fast here, what kind of endpoint paths it has been hitting with different API operations, where you got a 200 or 400 codes back. And some of those are successes and some are errors, but some are expected, for example, that you can't delete anything that hasn't been created before, or you can't delete anything where you don't have the proper access rights to. So those things will all show up in your summary of these operations. And eventually you can also get into the details and see what has actually happened behind the scene and pick up the messages, the body, and the details of the individual tests to get going with it. Right. So, yes, so this is basically brand new. It's been in our product for a couple of months now, and is a good extension of our already existing test and monitor capability that's in there. So there's a good way of creating these tests automatically. There's also a capability in there that lets you enhance or create your own assertions and do it more in a traditional way of testing, but also combine the test generation with the additional assertions that you want to build to it to have a proper testing of your API backends. And yes, this concludes the demo. Get back to my slides here. Eventually you can test a lot of these pieces here online. So for the Gopher as a service, you could see that there's a way you can just do it online and see how this feels and how this works based on a natural language utterance. And also for the auto test, there's quite a bit that you can look at. There's a white paper published for both Gopher and for the auto test capability. And yes, it's something obviously where we came up with the first version, and this will continue. You will see more things that are interpreted through a user interface and maybe less as a configuration file if you like that, and probably additional and deeper integration into our Cloud Pack for integration releases here based on this technology. Questions?
What's the test framework that is underpinning this capability? Is there a particular framework that you created for this work specifically? Or, I mean, what I'm looking at is, say, if I go with this approach, what sort of knowledge should my test engineer have to, say, upgrade or update the test framework as such?
Yes, so you can use the auto test framework basically with your own testing suite. So it is meant to be an extensible framework that we've built and published. We have specifically integrated into our test suite, but not everyone has basically our test suite as a standard and has made an investment before, so you can use it in different flavors. But the experience we've seen, you will only get when you do it from our path here. I mean, you could potentially use the auto test that we've seen and you just feed it an open API specification, which is completely separate from the product that we've seen here. So it is operating autonomously in the sense that we have it here, but it's intentionally a framework that can be used otherwise. So the core asset is actually the AI and the interpretation of a well-formatted open API specification.
So can you train your AI with your existing collateral, for instance, your current assertions, etc.? Can you feed those in so that it kind of recognises that again?
Yes and no. I don't know to what extent the learning capability is basically persistent for future testing cases, or if you basically always start with a new specification and it learns while it's doing the tests. That's something I would have to take away. If it's I think that's where you're coming from. It's a proper AI framework. Every test that you run would feed into the training of the API and would get better over time.
That's right. The other thing is,
I cannot really confirm how far this goes into that direction, but I can find it out.
Another place too is like your domain language might have specific terminology that you might wish to make the AI aware of, such as different organisations have say a different definition of what a service is. You know, it means a lot of different things. And,
so it understands and has less failures. Yeah, that's a fair point. But I have to take that back specifically. It's too fresh for me as well. I would assume there's issues. I mean, if maybe they call some sort of service similar to a product, and then it would, basically misinterpret it with a connector that it's using, although it's meant to be a backend service or something.
That's right. So I know where we work. There's always a bit of confusion between what an account is and what a service is.
Yeah. Fair point.
Things like that.
Yeah.
And, in the test suite, can you edit to add non-functionals or system reliability types tests as well? Like the number of hits it can hit through that API, or how far the response times are, things like those?
That's a fair point. It shows you response times, I believe, in the reports. But, and you can limit the number of hits you do in specific directions and calls for different operations potentially. I don't know to what extent it goes further than that, would have to find that out. But I think it's, for the purpose of what it's designed for, it's doing the job quite well, because you have to understand it's not based on existing analytics data and specific data pieces that you feed into API testing, which is also a form of API testing. It's meant to generate the data pieces itself and make it fit to the specific API that you've specified out here. It's good. And
Just have a similar question. Does it do the load testing on a specific API, or?
It's not meant to be a load testing in this case. It's a functional test of API. So semantic and syntactic
What you could do is
integrity of the API. Load testing would be a different piece. I mean, there you would go into different dimensions because you need to have basically a carrier that can do lots of repetitive calls and scale up and down as you need it.
what you could do is use this to generate your load test case.
Yes.
You could sniff the traffic and build your load test.
Yeah, you can actually look at what it's did. And if you have a set of specific calls that are applicable for your load testing, you can use this as a starting point and then hand it over to specific
The
requests.
extension can go from the auto-generated to the manual ones.
Well, in this case, I guess from the auto generator to your performance test suite, to your
Or any
load
test,
generator.
yeah.
Yeah.
So this is only per API. Can it be cross API? Call this set of APIs first and then continue calling the second set of APIs?
I mean, it's a test suite we've seen, and you can obviously register different APIs that it constantly goes through. Well, if it's part of your API specification, a dependency on other APIs that you're subsequently calling, then this would be respected by the test, and I would expect it to show up. Yeah, but eventually you will still have boundaries, and you will have several APIs that flow into a test suite, essentially, to make it meaningful. So it all depends on the open API specification, more or less, how well it is defined and what it includes and what it not includes.
Does it support like event-based callbacks?
You mean like in...
Say for example a service ordering API, you submit an order and then you want to get in-progress events coming back as to the order progression?
Like in an asynchronous API context?
Yeah. Because that's part of your API exercise.
Yeah, I mean the asynchronous API can just look at like a normal REST API. It just doesn't know that the backend piece of the API is asynchronous. So in that sense, it would work against those type of API specifications as well, I would assume.
Because part of that would be, I submit a create, and then the next one I want to submit a modify test, but it can't be modified for task point no return. You should get an error back. In terms of API testing, would it be something that you can specify, or it's going to be smart enough to try to do that sort of stuff?
Yeah, I don't know if I fully understand. I mean, it's as I stated, it's basically reacting upon the responses that are coming back. And if it sees that a specific testing path doesn't lead anywhere and doesn't make sense to pursue it further, it would probably drop it or modify it and pursue the other testing path. So if a backend system is not available or subsequent API or a specific piece of information that is not coming back from one call, but that is needed for the progression of the API, then that is flagged as an error and stopped there. So it's intelligent in that level.
That subsequent one is asynchronous notification. It's not a part of the initial synchronous notification.
Yeah.
It's a notification that comes with additional information. If you're submitting an order, you might get an acknowledge that you have received it but not accepted. But the acceptance comes as an async notification.
Yeah, yeah. It's a good question. I mean, that is very specific for an async scenario.
But that's what a lot of APIs do these days.
But if it's part of the specification, it can wait for it, I would assume, and would run in this.
The specification is actually specify the sequence.
Yeah, exactly. And that's the whole proposition here. If it's properly specified out, then I would expect the tool to interpret it right. Or it needs learning, in that sense. But why shouldn't it?
I have a question. If the API requires some like a token validate authentication, can we still configure in the test suite?
You mean to test the authentication piece of it, or?
Yeah, because some API may require some token, right?
Yeah, you have different means to configure your authentication. Yeah, I mean, just for the demo purpose, it was just username, password, but it works with token-based authentication like OAuth and OIDC. That shouldn't be an issue because that's the main purpose, so to productionize those APIs. And there's ways to focus on specific security testing as well, which is part of the package. But I don't have the details on it. We'll probably have to delve down to the links as well in that sense. All right. Yes, 50 minutes. I think we have a wrap if there's no more questions. And yeah, please look at the links or come back to us if you have any questions or appetite or something. And we could certainly extend the discussion and go deeper. Or visit us at the booth where we can actually look at this hands-on. All right. Thank you very much.
Thank you.